Welcome, everybody, to the most difficult chapter that you'll be going through this school year. It is called rotational motion. So let's take a look at the question and jump right in.
Wait, you're serious or no?
No, I'm serious.
Oh, you serious?
Yeah.
Great.
Hey, with the way you guys did on this last test, this should be no problem for you.
What was the average, do you think?
I don't know, but it was, I'd probably say high 80s.
Wow.
I just want to say that I went in and I said, I'm hoping and planning to get a B. And then once I finished, I was like, okay, 25 out of 30, that's my guess. And then I got a 26. Yeah.
Nicely done.
Hey, yo, guys, I went in thinking that I was going to get a 0, but I got a 14.
Hey. The only important one, how did Sarah do?
I got 28.
See, you don't have to quit your job.
I know, I was very glad for that.
Ben,
I was like, oh, precious.
he's going like 5
Did I
minutes
also
after
get rid
the
of the
test.
I'm glad somebody noticed.
Yeah, I did like...
Good.
Wait,
I saw
let
you
me
do
see what
that.
I
The
got.
fact that I thought that I was going to
Okay.
make him quit his job.
Okay. Let's get to this. A perfect sphere rolls down a perfectly smooth ramp.
On the banana?
What is the role that friction plays here? Are those banana flavored? I love those.
I got a 27.
I actually like it.
All right, guys, we gotta listen here. Let's get through today. We've got 5 days of notes for this. So, yeah. Today should be kind of an introductory day, so should on Monday. Hi, Jaden. You know, if you change one letter in your word, one letter in your name, you'd be Raiden. That's awesome.
From the Mortal Kombat.
Also, we had a conflict.
Well,
Can I share something?
if it's quick, we gotta get rolling.
I grabbed my quiz and Sarah's quiz after we both turned them in. Every single answer was different. We didn't have one answer even remotely similar.
Oh, I'm sorry, Sarah. You probably failed.
Hilarious if you're both
So,
incredibly wrong.
I think we could assume that I didn't do very well.
I think we can assume I didn't either.
I'm sure you did just fine. Everybody thought they did bad on this test in physics. And you guys, for the most part, did really, really good.
I don't think I did so much. Every answer completely
So far.
It was not remotely.
like her answer would be like 112 and mine would be like 17.
In the grand scheme of things, that's not that bad.
I got Africa.
If we're talking about
Hey, there's butter. Okay. You can take the pass, yep.
Really learn
Okay, here we go. We are going to keep moving, whether you like it or not. If a sphere rolls down a perfectly smooth ramp, explain the role friction plays here. Well, without friction, it wouldn't be rolling, so it's necessary for the roll to occur.
Wow.
Also, because there's really no second semester AP Physics final in here, you don't really have to write these down anymore. Just throw that up there.
Whoa!
It's a different
Wait, you guys are still writing this down?
I don't think you wrote any from first semester down, did you? Okay. So, you can title your notes, Rotational Motion. Rotational Motion.
Is it going to be a lot of notes?
Well, 5 days worth. But you can never get enough notes in this class.
That's a rough start.
You think
so? Really? I already messed up. I jumped the gun.
That's okay.
I know I got right on my cookies.
What's the topic?
What's something?
And what?
Wait, what is it?
Triangles are circles.
Rotational motion.
I can see they're related, yeah.
Okay.
Okay. Rotational motion. Go ahead and put this in your notes. And then you can do this if you want to.
I got the Jesus fish up there.
Yep. Jesus fish equals angular acceleration. We'll be learning about that.
Oh, wait, no, is that supposed to be alpha?
That's something that should be on the back of a t-shirt. Yes, it is alpha.
We're just going to write it as Jesus fish from now on.
Stop drawing potatoes.
Better than the avocado.
Hi,
avocados
Jamie.
from last time. They were so cute.
I'm sure you did just fine. Try not to stress about
Oh, I see. It's not even that. It's that I give myself a headache taking it.
it. Oh, sure.
I was processing information at a higher rate than my brain could handle. You know, the worst thing is,
Wait,
I got everything right on the review,
Really?
and then for whatever reason,
You're
I
in
just blanked
general.
on it.
You cannot.
Well, maybe you did do really well. Maybe Sarah just was horrible.
I don't think it'd be fun. I got the extra credit right.
That was hilarious. I don't
Okay.
know how to do that.
So,
Let's go.
this is a picture of a circle. And this little red thing represents a string, and this is an object that's moving in a circle. This represents the angle. Now, when we're dealing rotationally with different things, we're no longer, yes,
What's that little fish?
We'll get that far.
that's Jesus fish, also known as angular acceleration. So-
you actually run like that?
Yeah, this is alpha. Yeah, this is legit. So, we don't really deal with position, velocity, and acceleration anymore. Now we deal with angular position. This is angular position, and its units are in radians. Rotational motion.
Hey, radians.
And what-
This is angular velocity. Its units are radians per second.
Rotational motion.
The units for angular acceleration are radians per second squared. Let me see.
Yeah, that's awful.
So it was.
Yes, that's awful.
Oh, so it's angular. So it's fancy regular.
Not as potato-ish as Sarah's.
I hope you got 100%.
So, these do have really strong connections with distance, velocity, and acceleration, as you could probably guess. X, or horizontal distance, is actually equal to angular position times radius. Velocity is equal to angular velocity times radius. Acceleration is equal to angular acceleration times radius. Centripetal acceleration is equal to radius times angular velocity squared.
I got some of that information.
Good.
This is all in the formula sheet, right?
Yes, this will all be in the formula sheet,
That's
but
awful.
the more you write it down, the more it's going to be in your head. And
All of the R's.
the more the better. Yes, R is radius. Yes. So, of course, if we're going to be dealing with these things, we got to deal a little bit with their calculus.
You don't have to.
I insist.
Really? You don't have to.
I don't want to jip
I
you
like
guys.
simple math. I can go back down there.
Hopefully everybody got that.
Mr. Heffler, I have a question.
Yes.
Am I Latina yet?
Are you a Latino yet?
Am I Latina yet?
I can't tell.
The mask.
I don't know. Can you roll your R's?
Let's see.
Rotational motion.
I can roll it when I say my name. That's about it.
You guys do like the clover thing with your tongue?
Yes.
I can't do it, and I think it's cool.
I can just do the roll. My tongue is the
Okay, guys,
fine.
I can like flip my tongue upside down.
So let's say we have a graph here, and we want to figure out our average angular velocity. You would figure that out the exact same way that you would figure out your average acceleration. If this was a position time graph, you would find the slope. The slope would be your change in angular position over change in time. In the same way that if this was position time, you could get your average velocity by doing change in x over change in t. So it's the same story.
So, you take the derivative.
And that's coming next, absolutely. So yeah, if we do that same graph, and we want to find the instantaneous angular velocity, that is simply the tangent line at any point. And I'll get all the calculus relationships up here on the same part. So we'll do the graphs and then we'll just write all the calculus stuff down. Yeah. Okay. So you can probably guess that we're going to get the same relationship if we change this to angular velocity. If we change this to angular velocity, and I'll give you some time to, if you want to rewrite the graph.
Okay, over there.
No, dude, my
Yeah.
dog is so bad.
Wait,
I've got, the earliest I've gotten to bed this week is like 12, 15.
Oh wait, haha. It's not.
Jaden, if I had some Apple peons, I'd let you have some.
Wish I had Apple right now.
If I had some MDMA, I'd let you have some.
I'm not that it was a great thing. Like, that's something I wouldn't want to take. Oh.
Are we gonna do this again for?
Slow.
No, this is the end. Because if we have a velocity, if we have a velocity time graph, this would give us our acceleration. So acceleration is change in velocity over change in time. So it's the same thing for angular. Change in angular velocity over change in time would be an average angular acceleration. Just like this over here, the instantaneous slope would be equal to our instantaneous angular acceleration found through derivatives, which I think I actually wrote down ahead of time. Good for me. Yep. So you're going to want to get this down too.
The best part about it is that I went up to him. He's like, this course gave me a headache, but I feel like I did good. I don't know if Sarah.
I could quite literally have failed. I think it'd be funny if you
Failing for you was like a B plus.
If they each
But
get like
I do
equally
agree.
the same amount.
What if
wrong?
Mr. Mason was right and we both get a 75%, even though he literally corrected himself and said 50%? But I thought it was funny that he would give us both a 75%.
Well, hypothetically, even if I get all the graphs right, I'm good there.
Were our graphs the same?
I don't know. I just looked at our answers.
I mean, I just graphed them on my calculator and copied it down, so.
I spent 15 minutes doing the wrong graph because I graphed it wrong.
But remember, my calculator
What if you
was
substitute
my
all?
calculator was wrong, and
What's it's the one has like a little
the
Hang on.
multiple choice where
Is it
everyone failed.
no I'm not talking about that. I'm talking about
What?
what's on the board.
It's like a sheet.
Is that like
You forgot one.
Give him like the X size, make him upside down.
No.
I don't know.
We were all
I don't know, man.
Well, there we
The snap that smiles back.
But look, the
Not that one.
second
That one looks a little
is
devious.
now under the water
Under the-
level.
Oh yeah. Yee. I like that.
You're welcome.
I love our Katie Sarah moment.
But is the virtual class on?
You
Is he
know,
recording this?
the future
Yep.
kids. Well,
I apologize to our kids that have to watch any videos that I'm in.
I don't think he knew.
Look at that circle.
Even so,
That is a great circle.
Thank
The
you.
only I
I was
reason-
impressed with your other one too. But
Oh,
this
thanks.
one being dotted is wow.
The only reason I'm glad that I wasn't in comparative origins last semester was then they would hear me talk in another video.
Yeah.
Oh, yeah.
And it would be bad.
Cute.
So let's just briefly take a look at what you just wrote down. It's your basic calculus relationships here. So, I can't read from the screen. Angular velocity is the slope of a position function, angular position. This is the main thing you need to remember out of all this. Angular velocity is equal to the derivative of angular position, and angular acceleration is equal to the derivative of angular velocity.
So is that an average angular velocity?
Yeah, we don't use that very much. but it is what it is.
Yeah, that's average fish.
Average Jesus fish.
Not even gonna remember what that actually means.
It's just
All
gonna be
it's
See,
gonna
the
be
drawing
fish.
through the W on the bottom right makes me think of like a torch.
Yeah, it kind of does.
Or like one of those neck pillows. The bottom right.
All right. So this is a perfect circle. I dare you to draw one as beautiful.
Then I'm not drawing.
And this is the top of a car. You can't draw it as beautiful as mine either. Bird's eye view, car's going in a circle. That's what's happening here.
There's some fun. This is an example, right?
Yep.
Okey-dokey, perfect. Oh, this is sad. Circle? Yeah, because like the dotted line like crosses me. It's bad. I think my car became a pentagon, which is fine. And my zero became 6. Oh, the 250.
What if the Jesus fish are little sharks? Remember when we said we were gonna make them all the examples sharks?
Yeah, this is the first example.
I mean, I have investments for retirement.
Wait,
But-
can that be a shark? Flying around?
It's a Roth IRA.
Yeah, it's
I
a
do
shark that's swimming in a circle. It's not a car.
Pay some attention to the
It's not very
forex
fast.
market.
Well,
That's
yeah, it is. It's a cool shark.
He's a super shark.
He's creating a vortex for all the fish in the middle of the sea. And then he'll just go, whoop!
He's a smart
What class is that
He's
for?
a smart shark.
Oh,
But he's, it's a big circle.
Me and Ben
too.
just had a
It's big
conversation one day,
He
and
has
we're
to
like,
start
"What
out
this
far and
and
work
we're
his
like,
way
alright,
in.
we did it.
What if
There
it's
you
like
go.
bunch of
Hurting.
sharks?
It's a hurting shark.
We're learning as we go.
Cool. Just don't risk too much.
I don't know which
We're not.
tornado is.
Okay. So here's our example. We've got a radius 250 meters, velocity is 25 meters per second. And if I wanted to solve for angular velocity, that's simply equal to regular velocity divided by a radius.
So it's 1 ton.
Yep. Pretty easy there.
And then you use that to solve
I thought that you liked fractions.
centripetal.
Me?
Yeah.
I don't like fractions. I like decimals.
Who likes
That's
fractions?
Ben likes fractions.
Well, what teacher likes
Ben has a
fractions?
crush on fractions.
Yeah, probably.
Mason makes us use decimals.
I write decimals in my fractions.
I think Mason only likes fractions when you're like using it in a way that it's just easier to work with a fraction.
Mason will do fractions a lot easier than using decimals.
So,
Wait, no, I thought it's 0.01. It's not 0.1.
25 divided by 250.
Did you square the
No, you
angular
didn't square the
velocity?
angular velocity.
That's okay. So
Is
it
that
doesn't.
No, I think that's right.
It's
I don't know about the
'Cause-
answer, but it's not.
Oh,
very
I see what you mean. I forgot to write it in.
If you square it, it would be 1.
It would be
It's
0.01.
math.
It would be 0.01, which
Yeah.
would give you 2.5. So like
Yeah, you did it.
he did the math right, but he forgot to didn't note it.
We're smart.
Yep.
We got it.
I was a little confused with 2.
I was trying to figure it out too. So I was like 250 times 1/10 is only 25.
So pretty basic stuff here. Any questions on this?
No.
What did we solve for?
We solve for angular velocity,
Oh,
and we solve for centripetal acceleration.
I thought that it was like you.
So a quick note on angular everything. So when something's moving in a circle, you know, if you're on maybe a merry-go-round, the outside horse would have a bigger regular velocity than one that's closer to the middle because it's got a bigger circumference that it's covering in the same amount of time. But in terms of angular things, its angular velocity and its angular acceleration would be the same. If you have the same number of revolutions per second, you've got the same angular velocity and angular acceleration. So kind of keep that in the back of your mind there.
That makes sense.
Good.
Mr. Hathaway, how
Yeah.
What does the fish stand for again? I want to write down.
Alpha Jesus fish.
Angular acceleration.
Remember, Jesus is Alpha and
Thank
Omega.
you.
Jesus fish is
But he's
the
only
alpha.
alpha in this situation.
Jesus is the alpha.
I'm
It's,
the
Alpha. He's
disconfigured
beginning and end, which is Alpha.
Ooh, draw a card. Yes, I knew
So,
it was.
like, yeah.
Nelson chooses
It makes
acceleration in
That's
italics.
a good card.
That's actually not bad. That's probably better than any other car I've drawn.
It looks like a cookie car.
I was thinking like when like the Boy Scouts do like the race thingy. What are those things called?
Oh, the
Derby?
Yeah, that's those vibes I was getting.
I did too.
I thought Rob.
I got first, and then my brother was upset that he didn't get first because I got first in the family event or whatever, and so we had to share the trophy.
My brothers would do
Participation
Rangers
awards.
and do the Pinewood Derby,
At
but my
America.
mother said she didn't want to do Rangerettes, so she wasn't letting me.
We also did what's the one with the bubbles that you would have to blow through the straw? Yes, I got first or got second in that. Yes, I was very good at that. There was also only like one other girl who would go against me.
That's hard.
gorgeous.
Look at how pretty it is.
Love it.
So we're going to solve for two things here from this car wheel. I want to solve for its acceleration, its regular acceleration, and its angular acceleration. So if I want to solve for, let's just take a look at angular acceleration. It's equal to regular acceleration over r. So I'm going to have to calculate this regular acceleration anyway. But I have to do this first because that's the only way I'm ever going to get Jesus fish here. So if I want to solve for regular acceleration, remember that acceleration is simply equal to change in velocity divided by change in time. And I have enough information to figure that out. Final minus original is 30 minus 0 over 6 seconds.
Minus 0.
Minus 0 is going to get
Wait,
you,
where's the -0 come?
it would be like your original
I know,
time.
I like actually when you involve the -0, even though a lot of times I like skipping the step because I skip the step.
I just want
I like
you
it
to
when you
do
do
the
more work,
extra
but I
work
don't
that
like
I'm
it.
not
But
gonna
because I skip the step mentally, but if you don't do it, then when I get to the problem where there's actually a number there,
Right.
I forget it. And so yeah,
I gotcha.
you understand.
Don't forget 6 minus 0.
So then for angular acceleration, it's equal to regular acceleration divided by the radius, which is 0.2. And 5 divided by 0.2 is, of course, 25 radians per second squared.
It's too easy so far.
Actually, this is
What works in space?
I don't
It's
like
actually-
that little laugh that you just
Since we
did.
got it, this is-
So there's 5 days of notes. I would say that the first 2 are easy and the last one is easy.
So this should be
The middle 2 are
We're gonna skip
Difficult.
days 3 and 4, right?
we're gonna
What's
skip
the
them.
hard
No.
part about making
Well, hopefully I'm having a good day.
I'm sure you will be.
99 days out of 100 days.
It'll be 8th hour, so I mean a day can only be so bad when it's 8th hour.
The other part of the body. I don't know why that
What are you talking about?
I'm really not okay, but it made sense.
Okay,
And I thought I would share.
what color should I use? I'm done with blue. Green?
I
you want 2 markers? Wait, no, actually,
Give it
I
a
didn't
mark.
I don't think I can do that. I'm not talented enough. Don't write this down.
I was fully expecting to toss it over to the horse's name is Friday.
Now, like I said,
I don't know.
most of the things that are like straight line, like position, velocity, and time, have rotational versions. What's the rotational version of distance?
R.
Yeah, ch-ch.
Oh, theta.
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 It makes sense. If you spin it really fast, it might look
Wow.
This is the rotational version of that equation. It's on your formula sheet. If you want to write it down, feel free. But don't write down the first one. Let's go through some more of these equations. Do you remember that long position equation? Remember this guy?
Yes.
Oh,
I'll be
girl.
honest, no.
plus VOT plus 1
That plus VAT plus 1/2 I.
Because I remember you talked about like it's
Let me guess. Doesn't work.
No, it works.
Why?
but nothing.
What?
What's going on?
It says
Oh,
what?
what's all this shit?
Half Jesus fish.
Yo, wow, plus one half Jesus.
He's British.
I hope that green shows up on the screen.
Never mind.
Yeah, kind of.
I was gonna say, the first part
You might have to look close.
half closed with like a little bird.
Okay, we've also got velocity equations here.
Oh, look at my glasses.
Oh my god.
That made me really happy and I don't know why.
Equals VO plus AT.
Well, at least I'll remember.
Same thing.
Thank you.
For what? Equals Jesus time.
Jesus died.
It could be like a cursive O or like an A when you're in a rush. You know what I'm saying? Maybe an X.
Whatever you want, Raiden. So, in terms of
That's what it said when they walked in. If you change the letter.
Oh yeah. Go buy Raiden.
Mortal Kombat.
Yeah.
Got you.
My new name is Mrs. Majesty.
See, I got it,
Please
Mr.
respect
I appreciate that.
My name is Regina Belangi.
Regina George.
Princess Regina Belangi Hammock something.
The third.
Banana hammock.
Hammock. Thank you.
So, of course, we've got our time-independent velocity equation here. This letter could be an X or a Y, and of course, we've got a corresponding equation for rotational motion.
Theta, X and Y too? Wait, but it's circle, so it doesn't really matter, right?
Hang on, I gotta focus for this.
Oh, that's okay.
All right. What was the question now?
Is theta X or Y?
X or Y, yep.
It doesn't matter.
No.
It's a circle.
Yeah.
Can you turn this, so like if you gave us an equation and the thing was like going like this, could you just turn the circle to make it like that?
Sure. Why not?
I have to go like this.
So just kind of as a little recap here, in case you haven't figured it out already, X corresponds to angular position, V corresponds to angular velocity, A corresponds to angular acceleration. You probably don't need to write that down.
I thought we wrote that down already.
You probably did. I just want to make sure the folks at home know.
Oh, okay.
Okay.
It's all good. Well, no, you need to learn it more, so write it down more.
Here's another thing that I'd like you to write down, because when you're talking about radians per second and revolutions per second, things can get confusing. This would be a good idea to have this written down somewhere.
Every second, there are two
Every
rivers.
Are you
second,
gonna
every
go
hour,
through this?
thinking about her.
Yeah.
I'm
Thinking
Sarah
hell's
McLaughlin.
awful flowers.
I just made the pound symbol and it sincerely looked like the word is, and I don't know how.
Okay, I wrote pi instead of number. Wait. No. It's
My
supposed to
pi?
be a pi.
You guys ever seen like you know what the pizza tables look like?
Yeah.
That's how I draw my pie. I just draw like a little table, like up, right, down, just like a square without the bottom line.
I like the comparison to a pizza place table. Very creative.
What does right hand rule mean again?
I saw
Yeah, I'll
so many
explain
little chairs to go with the table. That comes on a pizza, and it made me really happy.
Vectors can't be negative, right?
Vectors can be negative.
Scalars can't be negative.
Right.
How do you remember that? Like, quite honestly, like,
How do I remember it?
no.
Oh,
X
yeah.
equals negative plus or minus
If only I remember
square
things
root
that
of
kill
C.
That's part of that. I don't think there's that.
If you wouldn't have looked at my quiz, you could be very positive right now.
Oh, I would be so positive. I felt so good about that
So why did you have to wreck it?
because I wanted confirmation that I was proud of myself, and then I was like, hey,
And then it backfired majorly.
I changed every one of my answers at least once when I realized I did something wrong.
I'm gonna be honest.
Oh,
The first
no.
one we had to take the derivative. I forgot how to take the derivative.
I guarantee you a bunch of people, because the first question was around the y-axis and then around the x-axis. I guarantee some people do the x-axis and then the y-axis.
All right, let's take a look at this. So if we're looking for angular position,
What?
and it's something that we're trying to calculate. If you're given the information in number of revolutions, you got to multiply it by 2 pi to get this answer in radians. If you're given an answer in number of revolutions per second, in order to get that into angular velocity, you got to multiply that by 2 pi. No surprise, because that would give you radians. So in terms of the directions of these things, you can see it says right-hand rule here. So let me go ahead and just explain that real quick. Right-hand rule is if something's moving in a circle.
Right-hand rule.
What's that?
Right hand, left foot.
That's right. Right-hand rule.
Only use your right hand.
Oh, is that what I was asking about? If you could go boop.
Okay, I'll use this. So, let's say something is going around in a circle like this. So it's going clockwise. You can use your right hand to figure out exactly what direction that vector is pointed. You just take your fingers and curl them in the direction of the motion. So if it's going clockwise, I take my fingers and I make them go clockwise. The direction your thumb is pointing is the direction that that vector is pointing. So in this case, it would be pointing into the whiteboard over here. So you just take your fingers and your right hand, curl them in the direction of the motion. The direction that your thumb is pointing is the direction of that vector. So if it was going counterclockwise, then my fingers would go like this. And my thumb points in the direction of that vector, and it's coming out towards you guys. Make some sense? No?
Why? I mean, it would.
That's just how it works.
I
What does this
understand
vector
that it's
stand
going
for?
to confuse.
What's it stand for?
Yeah, what is this vector?
What? It's just
I know that makes me happy. But
when things are moving in a circle, because it's changing position, it's not going in a straight line. Sometimes they want a direction that the vector is going. It's not something that you would see, but where it comes into play is if, like, you have a big bicycle tire and you spin it, you'll feel forces in different directions when you try to move it. That's where that comes into play. It's not something you'd actually see. It's something that you would feel. And we'll get to that later on. So just take my word for it. That's how you figure out, from the right-hand rule, the direction of your vector.
You can only
So
go
I'm
two
gonna be
ways.
honest, I understand
Yeah.
that a little bit, not a whole lot, but I'm definitely gonna remember the demonstration.
Good.
So when it does make sense, I'll understand why. Why I remember. Why I know that this is the right name.
I'll just remember the time that he grabbed the lighter.
He said, "Now watch it."
That's-
He's standing his hand around and just
Right.
fight,
Grab a
fight.
lighter.
I suppose this would have made it more entertaining.
It's like you were using the force there.
Yeah.
Were you strangling the fire?
Glad that was on camera.
Hey, just have Placido. I bet you Placido makes a meme out of that one. Remember the one where you're like right into the camera and Placido made a meme out of that one?
Oh, did he?
Yeah, he showed us all.
Oh, yeah, that's right.
He's up to the camera like,
Okay, let's finish this off here for this whiteboard. Then we got a little bit more. In terms of angular acceleration, you would find its direction in the same way. But if you're speeding up, then it's going to be, or rather, if you have a positive angular acceleration, it's going to be the same direction as your angular velocity. If it's a negative angular acceleration, it will be in the opposite direction. So just make sure you have that written down. When it comes into play, we'll talk more about that at that time. Okay, last thing that we want to talk about. Title this Rotational Kinetic Energy.
Don't play with fire, Mr. Hathaway.
I'm not playing with fire. I'm playing with fire. And I was like, I'll figure something out. Didn't happen.
I'm not playing with fire. I'm entertaining the children at home.
what if I like her?
Dr. Jensen just walked past the window. Setting something
It's
on
crucial
fire.
for our physics lesson.
Hey, so Mr. Hathaway, look.
Wait,
What
what?
does it say?
What does it say? I forget.
Point of view, you didn't round to 3 non-zero numbers.
Okay. Last couple things we're going to write down for today. And then we can officially turn our brains off.
My brain's already.
Yeah, I walked into
Brain's
that.
already off.
That's the guy who's.
It has nothing to do with you, Mr. Hasley. I enjoyed this class with my whole heart.
I appreciate
Oh, my brain is like just the amount of
just
brain
copying
capacity
out
I
whatever
have to
you
make
wrote.
this week
I
is-
never think of
I means moment of inertia. Whether you like it or not.
Inertia is a property
It-
of matter.
No longer stands for impulse. Sorry.
I thought it was impulse.
I really don't like
I thought
letters.
impulse was like
Just make a whole new
But
letter.
that's momentum. Yeah.
I was gonna say numbers, but
So
numbers.
that's not impulse, right?
Would you rather change it to J like the folks at College Board? Like
No.
impulse and the answer key, they label it
I'm
J?
so happy I'm not
I didn't
taking
think
it.
so.
Watching right now.
But why do we have two variables that mean the same thing?
Can I say something negative?
We ran out of letters.
Are we
So-
sponsored by college?
They are using like
Moment of
7 different
inertia.
languages. How did they run out of letters?
All right. So moment of inertia. Shh, let's finish this. Moment of inertia is basically a measurement of an object's sluggishness, how easy or hard it is to get it moving or to get it to slow down. So the faster and heavier an object is, the greater its moment of inertia is going to be. Now an object's moment of inertia is not just dependent on one thing, it's dependent on several, and we'll get to these later on. But you have to add them up when we start dealing with these specifically a little bit later next week. This is also known as an object's rotational inertia. It's the same thing. And the equation for it would look like this. You're adding up all the masses times the different radii. Usually you just have one. Occasionally you have complicated systems where there's more than one. Yes?
So would it be like sum of mass times radius squared?
Yep.
Okay.
Now I tell you all this so that I can give you a little expression for rotational kinetic energy. It's equal to 1/2 I omega squared.
I wish our letters had cool names.
And, we already talked about how this is kind of corresponds to straight line velocity. Inertia kind of corresponds to mass. So you can kind of see rotational kinetic energy, 1/2 I omega squared. It's kind of like regular kinetic energy, 1/2 mv squared. That's basically where it comes from. So, those are the notes. More to come tomorrow, or Monday. On Monday, you guys are going to learn how to do multiplication in 3 dimensions.
In 3 dimensions.
Yeah.
That doesn't sound fun.
And with that comment, we'll close.